So since he already gave away my title slide, you already know that I'll be talking about real-time AI and some of the data architecture that is required to actually put that into production. So most of you have probably seen a slide that looks something like this. It's a pipeline. You have multiple data sources that could be something from a sensor, something from a batch data set, something from a data lake, and you're ingesting that data into your pipeline, doing some feature engineering. Your data scientist team might be creating some new features, uploading those, training your models on them, doing model selection, model deployment, serving, monitoring, and I'm sure you've heard from a number of companies about their point solutions about each and every one of these boxes or even platform plays that encompass the entire thing. One particular interesting box is the feature store box. Particularly, the focus of feature stores has come into focus over the last few years with companies like Uber producing Michelangelo, DoorDash writing many different types of blogs about what they do with their feature stores, and the latency-critical applications that require new types of feature stores for real-time AI. What you might not know, though, is that Redis is used across many different parts of this pipeline. So to start, Redis Stream is sometimes used as a simpler alternative to Kafka. When you don't need the whole kit and caboodle, Redis Streams can often provide you what you need. Likewise, publish subscribe for messaging and triggering events like model retraining. Distributed training, where Redis is used as a CPU cache, such as huge CTR, which is NVIDIA's click-through rate model, and where Redis is used as a CPU cache to store parameters before going over the network. It's also used in things like Ray and Horovod, even though Ray moved to more of a gRPC approach. And Horovod, you can still use Redis as the parameter server as well. And then lastly, the one I'll focus on today is the operational ML side. So putting things into production with a focus on the latency critical applications, the real-time AI, that require a new type of feature store, or should I say, a repurposed database, as you'll hear today. So really what I'll focus on is that top box there, the feature store, and why, in particular, Redis is suited to be a feature store for real-time applications. So I'll talk about two things today in particular. One is Redis feature store, or rather Redis used as a feature store. And the second is Redis feature store for vectors. And really what you'll see here is that Redis is a data platform that's composable and suitable for a lot of different types of needs. But through this talk, you'll also see that there's many different companies that are actually using Redis, particularly for one type of feature store called an online feature store. So you've probably seen, once again, a slide that looks something like this. You're ingesting some data, and you have some feature platform that could be something like Featureform or Tekton, which supports Redis out of the box. Many different feature platforms are using Redis, in particular for that top right box, the online feature store. In particular, there are two different types of feature stores. You have your offline feature store, which I'm sure Databricks has told you about, Delta Lake, or many of the other different types of large data stores that are geared towards cost efficiency, but not necessarily low latency. As opposed to the offline feature store, there is the online feature store. These are geared towards real-time applications that require millisecond latencies. You cannot wait 100, 200 milliseconds from Snowflake to be able to actually produce real-time applications. You need those single-digit latencies feeding your ML model in production for those latency-critical applications. As explained earlier, there are a lot of different companies that are actually putting Redis in production as a feature store because of the need for those sub-millisecond latencies. You have AT&T, Gojek, Comcast for customer service. Robinhood wrote a great article about fraud detection. And DoorDash in particular has really enveloped Redis into their pipeline and wrote a number of great articles on their engineering blog, which I highly recommend you check it out, working on things like hash sets, compression, and everything else within the Redis ecosystem, and really making some great work towards online feature stores. DoorDash in particular has a number of different use cases for an online feature store, route optimization. Just think about all of the different things that have to happen in real time on the DoorDash app. They have to route the driver to the person that's ordering the food. They have to surface recommendations on the application so that you can get a better recommendation for what you might actually like to eat. And all of that has to encompass user data, location data, geolocation data. All of that data has to be consumed and placed into a feature store that's still going to provide you a millisecond latency in production. So DoorDash, I love this quotation because it really gets at the heart of why people are putting Redis into production as their online feature store. I'll take a second to read it. I don't usually read from slides, I promise, but I really just do love this quotation. A large-scale feature store used under the requirements for high throughput, batch random reads, and the constraints of low latency is best implemented using Redis. Redis is not only highly performant, but is also the most cost-efficient solution under these circumstances. And that's a key. It's a trade-off. You don't just need performance. You also need to put this in production and have it not swamp your service in terms of cost. And there are a lot of managed services out there that you can put into production as your online feature store, even for latency-critical applications. However, a lot of those will have costs go through the roof because of how they are managed and of how the costs are structured. Redis provides a ton of different cost and pricing avenues that actually make it much more affordable, in particular for large-scale companies like DoorDash. Again, one of our great partners, Tecton, who, like I mentioned earlier, provides that entire feature platform and definitely incorporates Redis Enterprise. They said, results show that our benchmark workload on Tecton, Redis Enterprise is 3 times faster across median and tail latencies being the most important one for these latency critical applications, producing single-digit millisecond latencies and 14 times less expensive than Dynamo. And that's the case. A lot of these managed services have costs go through the roof. And that's something that when you're running machine learning in production, makes it prohibitively expensive to extract business value from your machine learning pipelines. So not only do you have to have an online feature store that is performant, but is also cost efficient. The second part of this talk is about vector similarity search. It's a relatively new, although a lot of this field is very new, piece of the machine learning pipeline. And it's a way to benefit from unstructured data in production. And to me, it's one of the most incredibly interesting parts of the field because truly the barrier to entry is very low. And I'll explain why here in a second. So what are vector embeddings first, and how are they used? Well, vectors are a way to represent unstructured data, whether that unstructured data be text, images, videos, etc. You can represent any of them as a vector within a subspace such that they can be related to each other and the distance between them can be calculated. When indexed in a vector database, this provides you an incredibly powerful search mechanism for anything from videos, text, images, any type of unstructured data. The reason that this search is so fast is because it reduces the dimensionality of that data down to something that can be searched over and indexed very quickly. Indexed and then searched over, I should say. There are multiple ways to calculate this distance. You see some up there, Euclidean, and many other ones that you've probably seen in just math textbooks in general, Shabaev, what have you. And what happens is that those vectors inside of your vector database are not only indexed with multiple different types of indexing algorithms, you know some probably like Google SCAN, hierarchical small navigatable worlds, and even just flat brute force. Vector embeddings in production look something like this. So audio data is another example, but that data is then consumed, fed to some type of model, often an autoencoder or a transformer, and those embeddings are then produced and copied out of that model while that image, video, text is going through the forward pass of that model. Once those embeddings are created, they can be stored in a vector database. What's interesting about Redis is the new capabilities and data types supporting vector embeddings. Now, vector embeddings are a data type within Redis, so it's not just a cache anymore. It's a full data platform that incorporates many different types and pieces of the ML pipeline and ML workflow. In particular, the powerful part of this is Redis Search. Redis Search gives you 2 different indexing algorithms, multiple distance metrics, and support for hybrid queries all in our public preview. What this gives you the ability to do is, at the speed of Redis as a cache, give you the ability to not only put embeddings inside of your database and search over them, and index them, but also search over them and surface them to your users for any type of service that you're putting into production. One important part about this is hybrid queries. You probably have some type of search in your platform or your service that provides the user full text search, tag-based search, filtering, etc. What's really powerful about that is it's very opaque to the user, and it's very easy. But that combined with something like vector search is even more powerful, and I'll show an example of that in the demo I'm going to give in just a second. Vector search has many different applications, and you see a lot of them in production today. You probably actually don't even know that you're using it a lot of the time. Every time you log into Netflix, for example, you're seeing an application of that. Visual search, so being able to say something like, wow, I really like that couch. Find me a couch that looks like that. Retail companies all over the world are putting that into production because it's an easy way to find things that you like. Natural language search, that is one of the most powerful applications. Being able to say, I'm a construction company, and 10 years ago, we did a project where I had this one problem. And I'm now having that problem again. I put in 4 or 5 keywords about that project that I can barely grasp from my memory, and then all of a sudden, that document surfaced from the tens and 20s and thousands of documents that you have inside of your database. And that's just one example of that type of information retrieval, law firms, construction companies, that people are putting into production. Recommendation systems, I went over this, but it could be anything from recommending a movie to recommending a book. One of my new favorite sites is a site that actually uses vector embeddings to suggest you new books. I'm a bit of a bookworm, so I love that site, and I spend way too much time on it. Let me show you what an example of this actually looks like. So Redis has a fast API integration through our Redis OM clients. It's essentially like if you've ever used SQL Alchemy, like in ORM. It's very similar, except for it just uses Pydantic, the data validation framework, in Python. And so what you can do is define your models in Pydantic, and it just looks like data classes. It's incredibly simple. And so with that integration and fast API's integration with Pydantic, you get really interesting API routes that are very clear that look like this. So I'll kind of quickly go over this. You'll see this actually working in a demo here in a second, but this is a post route, essentially, that we are querying the vector search inside of Redis. We're saying, give us a list of products based on a product. So in this case, we are a user and we are saying, I really like this product, find me other products that look like this. We create a query, retrieve the vector embedding from Redis with single-digit latencies, where that vector embedding is stored. And then we take that vector embedding and then we perform a Redis search query with that vector. We then can asynchronously wait for all of those products to populate on the page. And because of this integration with Fast API, all of this is asynchronous and at the speed that you'd expect from Fast API. So now I'll give a demo, and this is something I want to preface by saying I was putting together actually for a conference in September, but we made such quick progress on it that we actually decided to present it here. And it's an incredibly powerful application of vector search, but really it's meant to be simple so that it's understandable. The code base is all online, and it's in my GitHub repo, so if you want to check it out, it's everything from the TypeScript React front end down to the code that you need to query Redis for the vector search. So it's everything that you need to put a very basic application up for this type of search capability. One thing that I want to point out on this page, and I found this graphic, is the types of encodings that you can use For this particular demo, I used Hugging Face sentence transformers as well as PyTorch image to vec. So that's just your base ResNet 18 off the shelf, trained on ImageNet and Hugging Face Distill Roberta, I believe it was. And once again, I didn't fine tune any of these models for this demo. I didn't train it on this product data set. I pulled it from the API, fed all of the images and text from this product into it, model.encode, as simple as that, no fine tuning, and I was able to perform this demo that you'll see. So hopefully you can see that. The image resolution isn't too great so far, but we do have a high resolution data set we're going to use. So here you see the Redis Vector Search demo, and we call it Fashion Product Finder because it helps you find fashionable products. And so on this page, you'll be able to log in and load and cycle through products. What we're going to do first is search by text. And so what you'll see here is a Do You Speak green men's printed beige sweatshirt. Okay? And so Do You Speak, I believe, is the brand. I'm not quite a fashionista myself, but I do believe that is a brand. And it's a green men's printed beige sweatshirt. So when we search by text here, the vector that is going to be that 512 byte vector is what is going to be that is created from is the Do You Speak green men's printed beige sweatshirt. So in this application, when we click by text, what's happening is that exact route, or it's a very similar route, I should say, that's the image search route that you saw earlier in that code sample. So incredibly quick, incredibly simple. Let's look at the results. So on the right-hand side, you see the query text, which is that Do You Speak green men's printed beige sweatshirt. And you'll see that when we click that, what gets populated, the first 4 results are all from the same brand. It tries to find things that have semantic similarity to what you have shown. And so you see that those 4, along with many of the other ones that are presented, have aspects of the text that are represented in that query text. So the brand, green, men's, sweatshirt, lots of that is represented in the products that are surfaced. And all of this is coming back at the speed that you'd expect from an online feature store, but it's not only retrieving that data, it's also performing a full vector search at the same time. So it's querying that data, performing that vector search, and returning you all of those products along with the metadata. One interesting thing to point out here is the Redis Insight application. It makes it really easy to develop these types of applications because you can see exactly what's inside the database. And I found it to be helpful when I was explaining this demo application because you can actually see the vectors, even though obviously they're bytes, so you can't really see them. But they're listed there as the image vector and the text vector. And you'll see 2 different fields there, a hash field and a JSON field. So through Redis JSON, we can actually store documents, just like you would in a document store, inside of Redis. So JSON can come in and out of Redis, and that's how those products are represented. We then relate each of those products to a hash field, product : and the product ID. So that when we go and we want to say we want to do a vector search, all we have to do is formulate that key, that's that create query function, retrieve that vector, and then run that Redis search function on that vector. So in this case, we'd be retrieving that text vector and then running that query. Next, we'll do a visual vector search. So I picked the most adversarial example that I could come up with because I don't love when people just have demos that are really easy. You want to see the faults in this kind of approach. So here I picked a shoe that there's only 2 of in the data set to see how does it do? What does it do? And here we're going to search by image. It is a catwalk women ballerina black casual shoe. Yeah, I believe that. And what it's going to do is search for that image, and what gets populated, you see here, is pretty close. The first 3 look pretty good, and as I said, there's only 2 of them in the data set, so this is pretty adversarial. However, the next 2, not so great, right? Well, what's interesting about this is that you can combine vector search with traditional tag and full text-based search. And so we're going to do that again, but this time we're going to add that hybrid query attribute. So on the site that you'll be able to try out here in a second, I'll click this time women for the gender and footwear for the category. So in addition to doing that previous vector search, what it's going to do is pre-filter all of the results by these tags. And so you could do pre and post filters with these hybrid queries and create really powerful search engines with this kind of approach. So here you see the results populated, and all 5 are much more similar to the original query image. And so in this case, you can see how you go from really powerful text-based search with pre-trained, not fine-tuned transformers and PyTorch-based ResNet models, and combine that with the traditional search methods that you'll find on just about any site or service today. When combined, you can create really, really powerful search engines. So without further ado, you can try it. I hosted it on my personal website. You do have to sign up, but don't worry, you can put absolute garbage in there. It's just so that we don't get hacked. And you can run it. It's on a very small AWS instance, so please don't hammer the query image or query text, because there's a lot of people on the demo. Last night when we checked, there were like 400 people clicking through the products. It's been a pretty popular demo. I would have put it on a larger AWS instance had I known how popular it would be. But in this case, I'll wrap it up by saying there's a lot that Redis can do. It really is the composable data platform that allows for really interesting applications to be built on it. I joined this company because I was putting Redis into production as an online feature store. And I realized its value and how many things I could do with it. And so I wanted to work for them. And we are also hiring, so if you would like to work for us as well, please come and talk to me. But there's 3 key considerations that I always like to say when considering your online feature store, or really just your data platform for any type of machine learning pipeline. Ecosystem. How many tools support this? How many engineers know about this? How many active people are there in this community? How many integrations, existing products? How easy is it for me to switch from one to another? And Redis really, in this way, has an unrivaled open source ecosystem. There's really few things out there with as many client languages supported as Redis is. There's even some languages that I've never even heard of that we have a client in. Likewise, the feature store integrations that we have are also really powerful. If you don't have a data engineering team to go and support putting up your entire feature store or workflow, you can use open source alternatives like Feast or fully managed ones like Tekton. And what that'll do is spin you up Redis, and then you can do all of your normal feature engineering to feature deployment all in one service. It's extensible and open. You don't have to sell your whole company to one cloud. You can pick that cloud, and you can move clouds with agility. As explained in this entire talk, the custom capability is getting really interesting with the module ecosystem. You can turn it into a document database, as I showed in Redis Insight. You can turn it into a vector database with Redis Search. It could be a time series database with Redis Time Series. And it can also perform graph-like queries with Redis Graph. That on top of the fact that there's also 4 or 5 other modules that provide different types of functionality as well. So when I say custom capability or composable, I'm not just saying that as a buzzword. I mean there are plugins that customize the capability inside of this database. And then it's open core. You can go check out almost all of this code. Besides maybe Redis on Flash, which is held back for enterprise, all of this code pretty much is online. So if you're interested in how it works, go take a look. And then lastly, when you do need to upgrade for enterprise, when you do actually need to put this into production and you need to rely on it with SLAs that you can count on, with the 5 nines uptime and the whole deal, it's really about performance per dollar. What are you getting from that service, and what are you paying for it? In this case, with Redis, you get low latency, high throughput, and scalability when you need it. Thank you.
Wow, very cool, Sam. I had no idea I was using Redis when I was searching Netflix. So if anybody has any questions, I'm sure you all do, just raise your hand. I'll come on over to you.
Thank you for the presentation. And I have a question regarding to the Redis Search. So is then in customization, I can it provides, for example, if I have my own algorithm, or I need to fine tune some of the parameters of the existing algorithm, does that support it?
So in terms of the existing algorithm, are you talking about the indexing methods?
Yeah, like the similarity algorithms.
Yeah, so in terms of the similarity algorithms, it's really just indexing and then searching over that index and then ranking. So really what you'd be wanting to change, I believe, is the indexing methods, of which we support 2. If you're talking about distance metrics, we support 3 currently. It's LP, cosine, and Euclidean distance, I believe. And so there's usually something in there that you can fit to your need for the use cases we've seen so far. But if there's not, you should absolutely come reach out to us because we actually implemented one of those for a customer as well. So that's something we're definitely willing to work with people on.
Thank you. How much latency has increased after adding filters?
Can you say that one more time? Sorry.
How much latency has increased after adding filter?
Oh, okay. So after adding the vector search, how much does the latency increase? Is that what you said?
Filter category or
Adding the hybrid query.
Yes.
Yeah, that's a very interesting question. So that pre-filtering does add some latency. In terms of benchmarks, I haven't benchmarked this application, I'll be honest with you. But usually those queries come back in single-digit millisecond latencies. So you do have to add those together. So at that point, you're probably looking at low 10s to 20s in terms of the query. But like I said, I haven't benchmarked it. So it's all on GitHub, though, github.com/Sparty Redis Vector Search. So it's pretty easy to spin up. It's all in containers, just 2 containers, single-page application. So if you want to benchmark it, please feel free. And let me know what you get.
Sam, I have a quick question. If I'm a developer, I want to learn the APIs, I want to check them out, where can I go?
Yeah, so obviously our website at Redis, which is definitely where you'll find a lot of the documentation. In particular, if you're looking for kind of the customizable components, the module ecosystem, you should take a look at Redis Stack. It's a single Docker container. It comes with all of them. And so that's actually what this demo employs. Like I said, it's a Docker Compose with 2 Docker containers. It's as simple as that, and you get all of that functionality. You can spin that up. It actually will spin up Redis Insight for you, that GUI application I showed you, all in that one Docker container. And then I just have that one single-page application with Fast API. And so you can definitely look there, and it's a really good way to kind of learn about it as well as it'll point you to the documentation.
Cool. And then one last question here, since we have a few minutes. Say I work in an organization, I'm in a vertical like healthcare or life sciences. Do you have any solutions accelerators that can help me get up to speed?
Yeah, so I mean, we do work with a lot of those different types of customers in those areas. Traditionally, it's a lot in caching. Kind of why we're here is exposing people to the fact that Redis is not just a cache. It's really a data platform because you can perform any of these different types of activities all within Redis. And if you don't need them, take them out because it's plug and play. And so that's particularly what we're kind of here to talk about in particular.
Cool. And I just want to try it out right now. I don't have a huge budget. Is it free to sign up for?
Yeah, I'll go back to the demo too so people can see the link. Oh, there it is. Yeah, so you can try it out there. Also, definitely go try it out. It'll be hosted for the next couple days, and then we'll be taking it down to prepare for a different conference and revamping the GUI a little bit. I'm not the best of front-end developers, but getting my feet wet on that side. But definitely try it out. Let us know what you think, and if you have any feedback, please let me know on LinkedIn, or we have a portal on Redis.com as well.
Very cool. Thank you, Sam.
Thank you.
Go try out the website. Go look at the repos. Check out Developer Hub. If you have any other questions for Sam, catch him after the session. Thank you, everybody who attended virtually as well. Please remember to review the session. Thank you all for coming. Cheers.